Hi, my name is Nguyen, and today I'm revising on magnetic resonance image and spectroscopy, which is like the first picture is the MRI and the second picture in the MRS. So in our class, we learn how field and waves interact with matter. MRI is a perfect example for this. It's a way to see inside the body using only magnetic fields and radio waves. It is much safer than X-ray, and instead it uses electromagnetic properties of the atom already inside us. So next, everything starts with a massive superconducting magnet like the bottom left picture. That creates a static field called BO. This field is about 30,000 times stronger than Earth's magnetic field. As we study in class, protons have a magnetic dipole moment. You can think of every hydrogen atom in our body as a compass needle. Usually they point in a random direction, but once you are inside the MRI, they all snap into alignment with the BO field, and you can see it on the bottom right picture. Next, once aligned, we use a transmitter coil which acts like radio antenna to send out a pulse called the B1 field. Even though they are aligned, these protons are actually wobbling like a spinning top. So in our class we study resonance, right? When the frequency of our radio pulse matches the speed of the proton wobble, the protons absorb that energy. This nudge tips them away from the magnetic. We are essentially using an electromagnetic way to talk to the atom. And next, so Faraday laws. After our radio pulse stops, the proton relax back to their original position. As they spin back, their magnetic fields move across a receiver's coil, which acts like a microphone. The changing magnetic flux induces a tiny voltage in the coil. This voltage is our data. In spectroscopy, we look at how different chemicals like fat or sugar cause the atoms to wobble at slightly different speeds, allow us to identify the chemistry of a tumor. So to sum up, magnetic resonance is a combination of the electromagnetic pillar we study, like static field for alignment, resonance for energy transfer, and Faraday induction for signal detection. MRI uses this to draw a 3D map of our body, while spectroscopy uses it to identify chemical fingerprint. So it's a really useful machine. And thank you for listening.